Right, let's start with a free body diagram. We have mg, we have tension, and we have a normal force, and that normal actually goes all the way from the wall. And those are our three forces. And in order to do anything, we're going to need to know what theta is so we can get some components. And in order to do that, we're going to need to use some trig. We know that this right here is going to be half the diameter. The problem is giving us diameter. The whole diameter was 32 centimeters, which means that this little bit here, so if that's my triangle, this little bit here is going to be 16 centimeters. Tells us the wire, which is from here to here, is 30. But then we also have the diameter, so that's another 16. So that's equal to 46 centimeters. I want to know this angle. So this is an opposite and a hypotenuse, so that means the sine of that angle is equal to 16 over 46. And I don't need to convert those to meters in order to do this. And theta is equal to the inverse sine of 16 over 46. Some fun trick here. That ends up being 20 degrees. So that's my theta. So we've done some trig to figure that out. So now the next step is to write our force equations. Let's start in the x direction. So we've got the sum of the forces is equal to ma. In the x direction, I have a normal force and I have a tension component. So there's a little bit of tension that's going towards the right. And that's going to be the sine, because that angle there is my 20 degrees. This angle here will be my 20 degrees. So it's going to end up being the opposite. So that's going to be tension sine theta minus normal force is equal to ma. But because it's not moving, a is equal to 0. That tells me that the normal force is equal to t sine theta. Okay, now let's look at the y direction. In the y direction, still have the sum of the forces equal ma. But now we have the cosine component going up, because that's going to be adjacent to that theta right there. So that's t cosine theta minus mg is equal to ma. But again, a is 0, so that whole thing is going to be equal to 0. So t cosine theta is equal to mg. In order to solve for tension, which is one of the things they asked us to do, it's mg divided by cosine theta, which is equal to 45 times 9.8 divided by cosine of 20, since we found that angle. When you divide that out, you get 470 newtons. Then, now that we know the tension, we can plug that into our normal force. That's going to be 470 sine of 20 degrees, and that will be equal to 163 newtons.